Hello, everybody. In this series, I am going to be reviewing some of the essential concepts on the math section of the SAT to help you review and hopefully improve your score. Now, to talk about the section itself, it's a bit different than it has been in past years. Now, in the past, it used to be two sections. It would be calculator and non-calculator. However, with the digital version of the SAT, this has changed significantly. Now, instead of being two sections, it's what the College Board describes as two modules. And these modules do not make a difference between calculator or non-calculator questions. A calculator is allowed on all questions, and in fact, you're provided with a Desmos calculator, which is very useful, especially for graphing and for solving equations in a way that might be faster than doing it by hand. Now, what happens is each module is 22 questions, and so you'll start out with one module, and depending on how you do on it, if you do very well, you'll get a more challenging second module. If you don't do quite as well, you'll get an easier module. And so what that means is that the more challenging module, it will make sure that your score cannot go below a certain point. So it guarantees a higher score. Meanwhile, the lower module, because it's easier questions, it caps how much score you can get, meaning you get an overall lower score. So the second module does impact your score. Now, there is no order to the questions like there is on the English section. Instead, there are all sorts of questions mixed together. Technically, they say that the module starts off with easier questions and goes to more difficult questions, but that really is dependent on where your strong suits lie, whether you're better at algebra or probability or whatever it may be. But there are four main question types: algebra, advanced math, problem solving and data analysis, which is often just probability, and geometry and trigonometry. In this video specifically, I will be covering a key concept covered in algebra, which is linear equations in one variable. Okay, we are going to start off with a rather simple question. What value of p satisfies the equation 5p plus 180 equals 250? So let's just write that out here. Now this is considered an easy question, but it's still a key concept that we need to cover. So we need to find the value of p. So what we're going to do here is we're going to subtract 180 from both sides, giving us 5p equals 70. Now, in order to isolate p, we will divide by 5, giving us p equals 14, giving us answer A and allowing us to select our answer. Okay, for this question, it is saying the width of a rectangular dance floor is W feet. So let's draw this out. The width is W. Meanwhile, the length of the floor is 6 feet longer than its width. So that means that the length would equal W plus 6. Now it's asking what the perimeter in feet of the dance floor is in terms of W. So the perimeter, of course, is the length of all sides combined. So what we'll do is we will add all of the sides together to get our equation. So we've got 2W sides plus 2W plus 6 sides, giving us 2W plus 2W plus 12, ultimately giving us the equation 4W plus 12, which is answer choice B. This question is a bit more difficult, but it's nothing we can't solve. So it's saying that 3 times 2x minus 6 minus 11 equals 4 times x minus 3 plus 6. And with that in mind, what is the value of x minus 3? Now, I could solve this by multiplying everything out, all the coefficients out, and solving for x. However, there is a little trick to this, which will allow for an easier answer. So instead of solving for x, we are going to solve for just x minus 3 by factoring out a 2 here, giving us 6 times x minus 3 minus 11 equals 4 x minus 3 plus 6. What we can then do now is subtract 4x minus 3 from both sides. And we can add 11. This will give us 2 times x minus 3 equals 17. We can then divide that by 2, giving us x minus 3 equals 17 halves, thereby giving us answer choice B. This one is a bit wordier than some of the other ones we have already seen, but it's nothing undoable. So, Megan's regular wage is P dollars per hour for the first 8 hours of work, plus 1.5 times her regular hourly wage for work after those 8 hours. And so we're given that she worked 10 hours for a certain day, and that her total earnings were $137.5. What is Megan's regular hourly wage? And so that would be equivalent to P, which is in dollars per hour. So what we have to do now is create an equation for P and solve for it. So we know what she earned that day was equivalent to $137.50. And that is equivalent to the first 8 hours she worked, where she earned P dollars per hour. Plus, she worked 2 additional hours. So that would be equivalent to 2 times 1.5 P, because she gets paid more money after those 8 hours. So if we then multiply that all out, we get 8P plus 3P, giving us 137.50 equals 11P. Now if we divide by 11, we get P equals 12.5, giving us answer choice B. So looking at this problem, it already looks a bit complicated, because it's one of those problems where it's saying which of the following is true and lists out a variety of options that you have to choose from. Luckily, there are no answer choices that say they all could be correct, but there is a choice that says none, which is always a bit obnoxious. But we're gonna go ahead and solve it anyways. So, it's asking the equation 9x plus b equals a times x plus b, where a and b are constants, has no solutions, and thus what must be true. So, first we have to see what they mean by it has no solutions. So what that means is that when you solve it, the statement must be inherently illogical, where you get like 0 equals 5 or 0 equals 1, or just something that doesn't make sense like that, where two not equivalent things are seen as equivalent. Now, to get that, that means that the coefficient of x must be equal on both sides, while any constants that are being added to it will be different. So let's see this in practice. So we got 9x plus b plus 5, equals, and if we multiply it out, ax plus ab. So we know that the coefficient of x must be equivalent, so we can conclude that a equals 9, fulfilling 1. Now we must solve for what b would be equal to 5, because it cannot be that. So 5 does not equal 9b, because once again, a is 9. So we will divide both sides by 9, giving us b cannot equal 5/9, giving us the fulfillment of 3. Now you may be asking, but it could be 2, because, 9 times 5, that isn't equal to 5. It could be, but the thing is, that is not true in every scenario. So it can't be answer choice 2, because this is not always true when there is no solution. B could equal any other number other than 5/9. It could equal anything for it to have no solutions. So thus, for it to have no solutions, only 1 and 3 can be true, giving us answer choice D. This problem is a bit similar to our last one, where it is asking about how many solutions there are. The last one was about if there are no solutions, and this one is asking how many there are. So what we're going to do is we're just going to see what x equals, and from there we can determine how many solutions there are. So let's just multiply our coefficients out. So we got 150x minus 90 equals negative 90, I believe, plus 150x. So if we, as you can see, both sides are equal to each other, but let's just see how this plays out. Let's add 90 to each side. So 150x equals 150x. And then let's divide by 150. So we get x is equal to x. What an astute observation. But anyway, what this means is that there are infinitely many values, because no matter what x was, it's true they'll always be equal to itself. No matter what it is, no matter what number, all numbers, it will satisfy this equation, giving us answer choice C. Once again, in this problem, we're dealing with a no-solution equation. So we have to find the value of k, which would make sure that this equation has no solution. So to start out, let's just multiply the 3 out. So we get 3kx plus 39 equals 48 over 17x plus 36. So if we remember what fulfills this, we already have different constants being added. So that's already fulfilled. So what we need now is for the coefficients of x to be equal to each other, for there to be no solution. So let's set 3k equal to 48 over 17. Now if you divide both sides by 3, you get k equals 48 over, I believe, 51, which will then simplify to 16 divided by 17. Now, because this is a free response question, we can leave it like that. So for free response on the SAT, what it does is you need to fulfill 5 digits. So if you just wrote this, that would be fine. Or if you wrote the decimal form, that would also be okay. For our final question, we have another long word problem. So a science teacher is preparing 5 stations of a lab. Each station will have either experiment A materials or experiment B materials. Experiment A needs 6 teaspoons of salt, while experiment B only needs 4. Thus, if x is the number of stations that will be set up for experiment A, and the remaining stations will be set up for experiment B, which expression represents the total number of teaspoons of salt required? That's a lot, but let's break it down. So there are 5 stations overall, and we know that X is the number of stations for experiment A, and experiment A needs 6 teaspoons of salt. So that means it equals 6, which are the teaspoons, times X, the number of stations times A. And we know that experiment B needs 4 teaspoons, so we can put plus 4. But we can't multiply it by any one variable because we don't know what is the number of stations for experiment B. However, what we can do, because we know there are 5 overall, we can do 5 minus x. So we're subtracting from the number of experiment A labs set up. This will give us our equation if we just multiply it out. So 6x plus 20 minus 4x, ultimately giving us 2x plus 20, which is answer C. Thank you guys so much for watching, and I wish you the best of luck on your SATs.